Now, if you are a programmer, you're bound to run into bugs at some point. And in this video, we're going to learn how to get unstuck from these tricky situations, something we call debugging. Now, we'll start with the easy stuff from level 1 of debugging, gradually moving up to level 3, where we'll tackle more advanced debugging techniques. One of the simplest and most common debugging techniques is using print statements. Now, by adding print statements in your code, you can see the values of variables and track the flow of execution at different points in time. Now, let's say you have a function that's not returning the expected result. You can add a print statement inside the function to check the value of the variables and see what's going on. Another very fun technique is called rubber duck debugging. The idea is to explain the code to an inanimate object, like for example a rubber duck, and by explaining it out loud, you're forced to think about it more and you may end up discovering issues or flaws in your code that you just didn't notice before. Now let's move on to a more powerful tool called Debuggers. A powerful tool found in most code editors. Debuggers let you set breakpoints, which are basically specific lines where code execution pauses. So for example, when running the code, if a breakpoint is hit, execution stops, allowing you to step through the code, examine variables and observe program behavior. You can even change the values of variables to see what happens ahead in your program. For example, let's say you have a loop that's not terminating as expected. You can set a breakpoint inside the loop and use the debugger to step through every iteration of that loop. This way you can see the values of the control variables and figure out why the loop isn't stopping. Another invaluable tool in debugging, which is more of a preventive measure, is logging. While we previously talked about using simple print statements to track code behavior, logging takes it to the next level. So what makes logging so powerful? Well, unlike print statements that output information directly to the console, log statements can be saved to huge log files. This means that you can easily store, retrieve, and analyze the logs later for an in-depth understanding of how your code is behaving over time. And this makes it really easy to assess the health of your huge code base. While this might not be needed in your side project, which maybe consists of a few files, but in huge companies with large code bases, logging gives a really good idea of the health of your code base. Now, what's really cool about logging is that you can customize it to your own needs. You can set log levels to control the amount of detail you want in your logs. For example, you might choose to log only critical errors in your production environment while capturing more detailed debug level information during development. You can also use log filters to focus on specific events, making it easier to pinpoint and diagnose issues. Plus, with log timestamps, you'll know the exact sequence and timing of your events. For example, in your production environment, you might choose not to print everything, but in the debug level information during development, it might be helpful to print a lot of extra information that might be sensitive. In short, logging is like having a detailed journal of your code's journey of execution. It's an essential tool for those tricky bugs that require a deeper investigation. And that's logging in a nutshell. Powerful, flexible, and ready to help you squash those elusive bugs. Another preventive measure in debugging is writing good unit tests. Unit tests are automated checks that make sure small pieces of your code, like functions, work the way they should. Here's how it works. For each piece of code you want to test, you set up test cases with specific inputs and outputs you expect. After making a change, you can run all your unit tests to double check that everything still works as it should. This way you can catch any new bugs right away and you don't have to manually test every single time. With a click of a button, you can test potentially thousands of functions. In short, unit tests are a powerful tool to keep your code in good shape and avoid bugs. By additional unit tests to your coding routine, you'll be on your way to building a solid and reliable code base. Sometimes the issues in your code are not just about logic, but also about performance and resource usage. Now, this is where memory and performance profiling come in. Memory profiling helps you identify memory leaks and excessive memory usage in your code. It shows you exactly which parts of your code are using the most memory and this information in turn can be used to optimize your program. Now, performance profiling, on the other hand, helps you find performance bottlenecks. It measures the time taken by different parts of your code and highlights the slowest areas. You can then focus on optimizing those areas to make your program run much faster. And if you don't want to do any of these, you can just paste your code in ChatGPT and cry for help. Well, jokes aside, this can actually be a good idea in some cases, where the code is small enough to fit into the actual prompt word limit. The best thing about this option is that you can have a back and forth conversation with the AI so that you understand the error in depth and make sure you don't repeat this error again. You can also ask the AI to add comments or clean up your existing code, which might prevent further bugs and errors. But of course, you can't expect the AI to be 100% correct all the time. Well, at least not till now. And that brings us to the end of our journey through the world of debugging. We started with simple techniques like print statements and rubber duck debugging, and then we explored tools like IDE Breakpoints and Debuggers. We also delved into the more advanced methods like memory profiling and performance profiling. Lastly, we mentioned an AI tool that might be helpful in some cases or maybe all of the time. Remember, debugging is an essential tool of the development process. And it's not just about fixing errors, but also about having an in-depth understanding of how your code actually works and improving its efficiency. And that's exactly what makes you a better software engineer. Well, that's it for today, and see you in the next video.